Hi everyone, I am Emanuele Pucci from Politecnico di Milano, and also on behalf of my colleagues from my group at Politecnico di Milano and from NTNU and Fachhochschule Bielefeld, I'll present our work named Defining Patterns for a Conversational Web. Our work starts from the fact that the web is still mainly a visual experience. You can see and just browse the web to find example of how difficult it is for people with different kind of impairments to have a quality experience on the web. Here, for example, we can see how the same form, although extremely easy to fill in for a sighted user, becomes completely inaccessible when using screen readers. There are vocal guidelines, of course, as well as other guidelines addressing accessibility. Yet the problem is that the most part of the web challenges are not addressed by them. Moreover, when applied, guidelines improve especially the technical accessibility of a web page code without focusing that much on the quality of the user experience, thus making all the efforts useless. That is why we decided to work on ConWeb, a new interaction paradigm to transform classical browsing into a dialogue-based interaction. The goal is to make website content available in a format that can be enjoyed by conversation. There is an example of how the ConWeb framework works. On the left side, you can see how a classical navigation mechanism based on visual hierarchy of content navigation through a visual-based interaction is reinterpreted to be provided into a conversational format on the right. You can see how the conversational agent welcomes the user on the web page by illustrating what is available in terms of content and functionality. The novelty here sits also on the possibility to perform actual navigational actions, as following a link to land on a new page to help the user browse through the web information by following the paradigm we're going to see in the next slide. This new paradigm wants to position itself between screen readers and conversational agents. The project started indeed as an assistive technology to help blind and visually impaired people browse the web, but it has revealed potentially useful application in many fields, both permanent and temporary impairments. Let's dive into the methodology which brought ConWeb to life. We started from two research questions. The first, how do we design effective conversational access to the web, refers to the identification of needs and browsing behaviors of people and then translation into conversational patterns. The second, how can we turn web pages into a dialogue, refers mainly to technical challenges about the design of technology enabling the conversational paradigm on the web. To answer the first question, we followed a human-centered process with a total of 26 blind and visually impaired participants to identify prominent challenge and related design dimensions for the definition of the new paradigm. The insight of each phase informed the next step and progressively guided the definition of patterns for accessing the web. The first part of the study addressed three main pillars: the user experience with web browsing, with screen readers, and with conversational agents. The first insights were deepened through questionnaires and follow-up interviews up to the elicitation of what we call preliminary challenges, the one we can see here on the right. The challenges were then addressed in focus group and co-design session to understand how the participants face them and identify with them possible solutions. We then defined patterns for conversational browsing by performing a deductive thematic analysis from the gathered material. We identified four design dimensions with their own patterns as co-solution co-designed with the same user. They refer to classical design dimension for the web, but their focus is on how to design a conversation. To start with, the first dimension is the orientation. The user has to understand how the information is structured to identify a map of the website. To do so, the view in the large subdimension presents the user with the main content as soon as the page is accessed. Then, navigational context acts as a sort of breadcrumb, helping the user recall the navigational history, and link predictability shows a preview of a link content without the need of navigating it to know what the target content is about. Indeed, for a sighted user, it is extremely easy to click on a link, verify the content, and then go back, while the very same operation gets extremely time-consuming with screen readers or other assistive technology. Once the user oriented themselves, it is very likely that they will want to navigate the content. It is then important to let them move not only sequentially, as a screen reader would do, but also vertically, digging down a specific topic, or horizontally, moving across different topics. During the co-design sessions, the participants indeed expressed the need to be able to ask specific questions to retrieve specific content, together with the opportunity to save pieces of information and being able to access them on demand in future sessions, as a sort of bookmarks, yet for specific pieces of content. Finally, the user would like to be supported in digesting content. The content reading dimension is about that. How can we deliver content into a conversation-likely forum? First, we identify the opportunity for a segmentation of content, especially the verbose ones, in order to let the user jump from segment to segment. While accessing a long pieces of content, the user will also receive a brief overview over them. Finally, the user highlighted the need for clustering content into main topics, a sort of tag cloud that can then be navigated and explored by conversation. The study also highlighted a type of operation which followed the user along the entire navigation, as default navigation actions, such as back, forth, etc., or the request to get back to the home page. We implemented the patterns into ConWeb, which is a technical framework relying on what we call conversation-oriented navigational tree to organize the web page information into conversation. For each page in a website, the C and T represent a hierarchical nesting of content elements and navigational structures, which recalls the HTML DOM organization but introduces new conversation-oriented elements. Each node in the tree, which we call conversational node, can be a content paragraph, a navigation menu, a link, or any other element in a web page that can be presented independently of the others and has a role in the exploration of the website content. Each node is associated with descriptions, which can be already available in each HTML code, alt text for images, for example, or purposely generated to enable conversation by means of indexing and summarization techniques. The framework was then tested with 4 users. Now browsing tasks were presented to them, and all of them were able to complete them. For each dimension, feedback and allow comments were gathered. In general, the user manifested a good attitude and engagement with the interaction paradigm that one considered easy to learn. The participants positively commented on the intuitiveness of content reading mechanism and the ease of moving along the different segments, and valued the Q&A patterns as one of the most useful features ever used. We want to acknowledge the limited coverage of pattern to static and well-organized websites such as Wikipedia. Future studies will need to test the framework also on more complex websites. Also, the diversity of study participants and the sample size will be enlarged with new and large-scale studies. We have balanced involvement of participants based on their diverse characteristics. Our research helped us identify current gaps in the web navigation with blind and visually impaired users, define a new interaction paradigm for browsing the web, and build a framework on top of it. Participants perceived that the conversational paradigm enabled a more natural interaction, allowing them to more directly express web browsing requests without having to enact complex user workflows operating a screen reader. They perceived a reduced cognitive effort of lowering the need of memorizing the structure of websites. During the studies, the possibility to extend ConWeb other prototypes of impairment also emerged, and the need for a wider spectrum of web-based solutions with high degree of personalization, as image style and speed aspects will be addressed in the future studies. More in general, in line with recent standardization initiatives, our goal is to promote the motion of conversational web by means of innovative web technologies that can natively support conversational access. With this, I wanted to thank you all for the attention and invite you to contact us to ask any questions you have.